what we're going to be covering today is a new open source project release from us here at Kasten by Veeam. So, and before we get into what Kubestr is, I'm going to touch on a bit more about the broader scope of our open source strategy going forward, but also talk about some of the challenges that maybe the traditional storage admin or storage operator developer is going to or has already in this world. So this is really the premise of the announcement, but we wanted to also kind of go backwards and talk about the whole open source strategy that we have from a Kasten point of view. So if we just a bit of housekeeping. So first of all, thank you again for attending. Obviously, whether you're catching this live with you guys or whether it's a part of the recording, I know we'll be sending it out to people that can't make it because of time zones. You should have all been automatically muted on entry, but what we'll do is throughout the session, we'll try and take breaks to look at what questions are coming in and use that function. But depending on the size of the group, we might be able to come off at the end and really just and have that discussion point and see what questions are out there. Now, more to the point, that Kubestr piece is under embargo. Although for those that have already seen that title slide and potentially gone out and maybe found Kubestr, you might see that the source code is already out there, and we're not doing anything with that. We're not taking it down. But in terms of structural release, so the actual press release is going to be going out on Tuesday, March the 30th at 8 AM. So any content that you decide to create around this, then please just hold fire on that. And this just brings me back to that first item around that thank you and welcome. We want to do more of these. We've got some more upcoming releases from a Kasten point of view that I'd love to extend the invites out to the community, and it works both ways, right? You get the, and I've been on many a side, at the same side as you guys, is that you get that information before it's released to public. You can write about that. You can put a video demo around that, all of the good stuff. You can ask the questions that you feel that need to be answered as well prior to it going out there in the public, and giving yourself that potential edge to having that understanding. So we want to do more of these. This is the first one that I've been able to do since kind of moving over to the Kasten side of the house. But yeah, we want to be able to do more. And there's a lot more coming that will allow us to do that. So for those that know me or not, just a brief introduction to me is, so I'm a senior technologist at Veeam. I've been here for just gone 6 years, obviously focused on from a product strategy point of view, but evangelizing our technology within the community. So whether that's virtualization, physical, cloud, or even cloud native, all of them are focuses of mine here. Try and get as much content out there amongst the community as I possibly can. Find me on Twitter mostly, but also been, as a lot of us have, around changing up the content wheel and delivering more content around video, YouTube, and a lot of those different areas. So that's me in a very brief nutshell. So before we get into it, I want to give a big shout out to Suresh. He's the smarts here. He's the guy that's done all of the engineering work for Kubestr. He works for Kasten by Veeam. He's very much focused on the storage element, which is ultimately where Kubestr is hugely focused. So big shout out to Suresh there. So before we get into it, I know that I think the invite might have been for well over an hour. Don't worry, we're not going to be doing 100 slides. I hope to do a few slides, but then get into the demo. There's only so much you can show from a demo point of view in a command line, but I want to show you what it is. But also I want to talk about our strategy. I want to talk about how the challenges are out there today prior to Kubestr, and then what Kubestr is in a nutshell. So I think from an open source strategy point of view, keeping it very high level, is that we understand that open source in general is critical to enabling our customers, but also a lot of us in the community. It enables us to do a lot more and achieve a lot more. By enabling the community and having these open source projects that you're seeing pop up from various different vendors, but having this innovation, this contribution angle where you're not just sat in your own team and you're creating your own projects, you're now sharing that with a wider group that ultimately enables us to go much faster in terms of development, but also different viewpoints. We're not just seen in that one particular like subsection of the ecosystem by us talking storage. Yes, we use storage from a backup perspective. Yes, we use it from a DR. Fundamentally, we have to use storage to a degree, but we're not storage experts at that. So it's very much a case of working with the community to enable the best of breed tools out there. And I think that's a wider strategy that we have across there. So, and this isn't new for Kasten either. Already out there, we have a project called Kanister, which is our own. So we innovated around this, and this is an application level data management tool for Kubernetes. So think about your stateful databases out there, being able to protect those in a consistent fashion from using an application consistent fashion, but also things like when you've got RDS coming in from leveraging an AWS RDS into your Kubernetes cluster as a place to store and use that database service. Kanister can also capture that from a consistency point of view as well. It doesn't just need to be, oh, my MongoDB or my NoSQL or my SQL is running inside the Kubernetes cluster. It could be leveraging an external source there. And that's the beauty of Kanister, which again is open source. Then a lot of the fundamental data mover technology underneath from a K10 platform, a Kasten K10 platform, is also leveraging a project called Copia. Now, not created by us, but hugely contributed by us. And this is really how you're moving data from A to B. And then we're just we're leveraging that to do a lot of the good stuff that we're doing, and obviously contributing back into the open source community around that. And then thirdly is the new release of Kubestr, which is what we're definitely going to get into today. So first of all, what are the challenges that we're solving here? And the first one is around, well, not all persistent storage is equal. And bearing in mind that the whole premise of Kubernetes is that it can run literally anywhere. Public cloud, name your public cloud and your managed service offering up in the public cloud. Then all of the other managed service offerings, bring that all of the different storage options that you have within the public cloud. Then you've got your on-premises and all of the, let's call it the traditional storage vendors that are absolutely bringing a story to the cloud native storage world. So you start to get an overwhelming choice of what that storage needs to look like. And then not even there, you've got other workloads or different workloads. I mentioned databases, but things like batch processing, like Kafka and other workloads that require that stateful set of data, they require different outcomes when it comes to storage, or they potentially do. And I think today, and don't get me wrong, there are ways in which to understand what that storage is and what it allows you to do, but it's not a very easy task. Maybe not easy in that if you're from a virtualization background or a cloud background, it's not necessarily the easy, you're not hitting the easy button to understand the capabilities of that storage that you have presented in front of you. So these are the challenges that we see. Another thing is, if you don't have those skill sets or you don't know what you don't know, or is your storage configured correctly? So we've got the CSI driver, for example, is very new, but it's growing exponentially in terms of vendors bringing their own CSI capabilities. So, and it's very easy to think that you've just set and forget that, and you've missed out things like volume snapshot classes. And these are the things we're going to get into, but these are also challenges. And there's a lot of different moving parts within a Kubernetes cluster. There's no real big Kubernetes easy button. It's pretty difficult to get up and running. So, and I think that last point is around the ideal situation is that you've got visibility of the storage that you're using the best storage for the job in hand, and you're not wasting any of it in terms of cost. And we'd all like that outcome, but actually it's going to cost you money for the best storage available and for the best technical validation. It's going to cost you the most money, and we know that you can't necessarily tick all of those boxes every single time. So what we're hoping is to remove some of those, let's say, challenges around the persistent volume storage within Kubernetes. And I think this, again, depending on where you've come from a storage point of view, from a Kubernetes cloud native point of view, virtualization, etc., benchmarking is not new. We've been doing benchmarking, at least from a storage point of view, since the beginning of spinning disks, understanding what different RAIDs could give us from an IOPS point of view, from a throughput point of view. And really, it doesn't change in terms of the outcome when it comes to Kubernetes storage. It's still storage underneath. Yes, it's faster because that's just the timeline of how storage has grown up or advanced or innovated with. But actually still being able to understand the capabilities of that storage and the speed of that storage, or the watermark of that storage, is still very much an important factor that we have to approach. And just to kind of go back full circle, is that, so this is a grab of the CNCF landscape from a couple of days ago, weeks ago maybe, and how this has doubled in terms of logos on here over the last 6 months, 12 months. And that alone just tells you how grown up the stateful, but the storage world in Kubernetes is growing. And just the abilities of being able to leverage something like the CSI driver, that is really the easy button for storage vendors to walk into the cloud native space rather than building their own in-tree providers themselves. But obviously we've still got those. A lot of the big storage vendors, you can see them listed here, they've obviously built in-tree providers that enable them to do that. So this is about being able to understand a bit more about that storage. And as much as I mentioned around the cloud having so many different options, storage having so many different options, then mixing the two, that, well, compute can also have a huge factor against what storage capabilities you can achieve, or at least the IOPS that you can achieve. We kind of just want to make it easy for the operators, for the developers to choose the right storage for their platform. So I kind of mentioned this already, but the solution is, well, let's find the easy button to be able to do this. So we know where our application, we probably start with our application that's in the middle here. We then might start with a subset of users that we know what the workload or the requirement needs to look like. And then that question mark comes when it gets to the storage over on the right-hand side, is, well, if we have X amount of users going through our application, storing X amount of data, what does the database, or what does the storage impact look like, and what do we need for that workload? Now, traditionally, we would look at what would take a snippet of what that would look like in terms of IO, IOPS, in terms of throughput, in terms of benchmarking, like getting as close to that application as possible so that we could benchmark against that. And then we'd see what that storage was capable of. In Kubernetes, yes, that could absolutely be done. We could go out there and you could go and create an application, a pod that creates a PVC, a persistent volume claim, that then goes out and creates a persistent volume. And then you run your application within that pod that runs something like FIO, but it's all a manual task. There's no easy button to be able to deploy that. And that's really where Kubestr comes in. And again, we'll get into more detail. And it's not just, another reason why I wanted to bring this up here is that not only are we seeing obviously stateful workloads appear now in Kubernetes, and quite quickly, it's not just the databases that we're seeing. It's also things around messaging queues and batch processing and things like that require that stateful storage. So then that leads us on to Kubestr. So Kubestr, and you can find this on kubestr.io, is really the easy button to identify your storage that you have available in your cluster, to validate that it's configured correctly, and to evaluate against that storage. So just to quickly drill into some of these points. So first of all, identify. So, and this doesn't, I think this is the key point here, is that a lot of things that we do at Kasten is around day one or day two operations and making sure that you've got backup of your data. This maybe looks completely on the other end where, well, we should use this on day zero and only use it on day zero to understand what the storage offerings that we have configured in our cluster looks like. Well, that's not strictly true, in that you should be benchmarking regularly on your cluster to understand what the storage capabilities are. The cloud is obviously changing in terms of storage options, so there might be new ways of being able to get better performance out for your application for probably less cost. But it's not just a day zero tool. So yes, it can absolutely be a day zero tool, but it should be used on existing configurations. If not, this is where we see the biggest uptake, or we hope to see the biggest uptake, because this is where we're going to unearth those misconfigurations potentially, or those storage types and storage classes that have been created and just left there and they're not being used anymore. So let's identify and give some visibility into that. Understand the performance that's available to them, but also that discovered the wasted resources, as I just mentioned. Then we get on to validation. Now, this is where we start to streamline and automate some of this process. So very much the first one is just going to do a kubectl, and it's going to look at the storage classes available, the volume storage snapshot, the volume snapshot classes available, and give you a report out. And when we go into the demo, I'll show you what that looks like. But from a validation point of view, this is going to make sure that your storage options are configured correctly, especially when you come to CSI. So the beauty of CSI is that, well, it's uniform across any CSI driver, in that snapshots are available, or the ability to leverage that same API. And that's really the easy button for the storage vendor, as I mentioned. So what Kubestr does here, and again, I'll go through this in an actual demo so you see it, but to walk through the process, is that when you run Kubestr, it's going to deploy a very lightweight OS, a pod. It's going to create that PVC. It's going to create that persistent volume. It's then going to snapshot that persistent volume, and then it's going to restore that. Now, that's going to give you validation that your CSI driver or your volume snapshot class is in a good state and it's configured correctly. Obviously, if that fails, you're then going to get the message to say your CSI driver is not configured correctly. And 9 times out of 10, that's going to be because the volume snapshot class hasn't been configured, because there's a varying amount of steps that you have to take, especially in the public cloud, in order to get that CSI driver properly configured for snapshots. So then that brings us on to the evaluate, and a very similar workflow in terms of down the bottom. But what this is doing out of the box, so from a version 1 point of view, is we're going to create that same, or a pod, again with a lightweight OS, and this time it's going to be injected with flexible IO. So again, a very traditional benchmarking tool that we've used for years against storage. It's going to create that PVC, it's going to create that persistent volume, and then we're going to run FIO against that persistent volume. That's then going to give us that simulation result against whatever that test may be. And again, we'll touch on that. What do we mean by multi-platform? Well, so the evaluate actually doesn't necessarily need to be the same as so with the validate, that has to be that's a CSI check, simply because the CSI driver consists of the uniform way of being able to deploy the storage in that from a CSI point of view. From an evaluate point of view, because we've got those in-tree provisioners as well, then this gives us the option to run against those in-tree provisioners as well. So you can compare against CSI storage that's available, but also with those in-tree providers. That if you go to, and I'm going to use AWS as an example, but you, out of the box, at least today, you get access to the in-tree provider, or in-tree provisioner, sorry. And then you have to manually go and create the CSI driver, or deploy the CSI driver, which has its own steps then to create the volume snapshot class, etc. So and that's for now. I believe that is going to change later on down the line. So there will be default to CSI later on in different Kubernetes versions. But for now, we've got the ability to leverage both. And I believe we will have moving forward as well. But from a multi-platform point of view, not only does this work, we've got Mac OS, we've got Windows, we've got Linux, the ability to use this tool on all of those operating systems from a developer operator point of view, but also obviously the nature of Kubernetes is that, well, Kubernetes is the same pretty much regardless of where Kubernetes is running. So as long as you've got kubectl access, you can run this automated test or this handy little tool for benchmarking as we're putting down there. So with that, let's jump into a bit of a demo. And obviously for now, this is what's available. So if you were to go to kubestr.io, in fact, let's show. So first of all, kubestr.io is probably the first place to go. And this is how new it is because we haven't even updated what the GitHub pages looks like. It gives a brief explanation as to what it is in terms of those identify, validate, and the evaluate. Small demo, and then using Kubestr and how you would use it. So what we're going to do is we're going to break that down into the demo now. And then here is where you'll find, and these source codes are available here as well. Download the latest release. And then this brings you to this page where you can grab the source code, but also those installers for your respective operating systems. So if we jump in here, and hopefully everyone can see that. But so I want to start by just really highlighting the simplicity of the tool. So I've kind of touched through what the workflow looks like and what it does, and absolutely pretty much the same as any of these small open source tools. It's really about making life simple for both the developers, but also the operators that are being pulled into these storage decisions, these environments that they may not be so familiar with. This gives us a little bit more of an easy button to be able to do that. So first of all, it's a very super simple command line. I've got some of these to run through, but so kubestr.exe --help, that gives you the available commands, and we're going to run through some of these. Just for the record here, I'm using an AWS environment, but obviously it works on others, and I've got an Azure one if we wanted to jump into that as well. But pretty basic stuff in that we can run a CSI check or an FIO check. But if we were to just run that identification element, then we would simply run that. It's going to validate the check of your Kubernetes cluster first. It's then going to run an RBAC check against your cluster to make sure that, well, you're allowed to do it from that machine. It's then going to check around the aggregation layer, so checking in on the APIs to make sure that you can do this. We're also going to get any warnings that you may also see when you're deploying your workloads. So things like Helm charts, this is where you primarily going to see things like CSI driver is depreciated in 119, but unavailable thereafter. And it's going to give you that insight into that very quickly. And then it starts to list off the available drivers or the in-tree provisioners that we have. So here you can see that I've got EBS, storage class GB2. If we want to run a test against that, an FIO test, we can, like I mentioned, and we'll get to that shortly. And then here we've got that CSI driver. Now, out of the box, when you deploy Amazon EKS, this is not installed. So you have to manually go and do this today. But you can see here that I've manually deployed the driver. I've created a storage class based on that driver, as well as a volume snapshot class. But here we've got the ability to do the FIO test, but also that CSI functionality. So if we just walk through this again as well. So here, from a CSI check point of view, we've got the ability to run a manual cleanup. Now, if you've run a CSI test and let's say, for example, your underpinning pod or persistent volume claim never got claimed, and it just left something in situ because there's a timeout on this, it will not automatically clean it up. What we can do is we can go in and we can find everything that has the Kubestr naming convention and remove that automatically using this. We can choose particular images. So this is where the help of the community is really going to come into itself, is that this automated approach of being able to have this as a handy tool. Like we're using the CSI, we're using the container image that is going to check against CSI snapshots, but there could be other areas that we've overlooked coming from the space that we're in. So it might be that, well, this would be good if you could do this or that as examples. So to get onto, and we can run a specific users, we could use a specific storage class, etc. All of the stuffs that are required, as well as the storage class. So if we take the example that we have here, so CSI check, I want to make sure that my CSI driver is configured correctly on EBS-SC, so my storage class, against my volume snapshot class, CSI AWS VSC. So if we hit run on this generally walks you through that process that I showed in one of the slides, is that it's going to go and create that pod. In fact, if I so here you can see, hopefully you can see, sorry, it's a bit small, is that you can see that we've got a pod now up and running, and we're now taking a snapshot, confirming that the snapshot works. So fingers crossed that works. And you can see our snapshot there. And then what this is going to do is this is going to then restore data from the snapshot back into the original application. So whereas this would have been like, and this is a documented step in pretty much all of the major cloud providers when their quick starts. They take you through this process, which is great for learning, understanding what it is, 100%. But when you come into doing this from a production point of view, you're also thinking about other areas. You're thinking about security. You're thinking about the application, the workload. You're thinking about other areas that you need to spend time on because you're potentially new to this world and you can't learn everything to get up and running. So this is very much okay, at least this is validating, or this is validating that my CSI is configured correctly. So, and then it gives you a report back, and we can output this into JSON as well if we wanted to use it as part of a wider CI/CD pipeline type thing to understand, to make sure to verify this before we move on to start deploying our applications or even updates, because things change a lot with the APIs from a Kubernetes point of view. So you can see here that the CSI application successfully snapshotted and restored from that. And now if we go back into here, the pods should have been removed. It's terminating, nothing like a good live demo. And the volume snapshot, so at least that one's gone. And that will go. So I mentioned around Azure, and this is really for a wider demo, but we could just change our kubectl config context and we could jump over there and we could run that test against that. But it's very much the same, as you probably could imagine. But then we get onto the evaluating the actual storage. So we jump back into AWS. We've got that same help command that will give you our options. And we're going to run through some of these. So out of the box, we use a default size of 100 gig file, and we're using 4K random reads and random writes, and we're using 128K random reads and random writes. That doesn't need to be like, that's just by default. So we can absolutely go and change that with our with what you want it to look like, but also you can put it to an FIO file, a configuration file. So again, open source, mini little tool that we've used for years, being able to take those FIO, and I'm going to touch on that as we go through the demo, is that we could pull one of those in. Maybe we've built one for our application that we know that is the modeling that it looks like. Well, let's run it against our Kubernetes storage and make sure that it's capable enough, or that we get the same results from that. So let's run that FIO test against our EBS persistent volume. So again, we're going to create that we're going to create the application, we're going to create a PVC, and we're going to create the PV against that. And this, the out of the box test with the 100 gig file and the 4K and the 128K takes about a minute at max. Now, as we get down here and we start looking at other bring your own FIO, then you start, this takes a long time because of what it's doing. It's reversing the sequential read-write access to that storage, which again, if you've got a certain use case or a certain application that runs that, then that might be what you need to benchmark against to understand what the capability is. So you can see here that I'm using the default FIO on the storage class EBS-SC with a persistent volume claim of 100 gig. This takes about a minute. And then what we can do is we can increase that. But what I want, so I will do that. But what I want to do is show the difference in performance, because one of the big things from a cloud point of view, a cloud storage point of view, is that you've got various different options. And that's going to be the next slide that we get to when we go back to the slides. But there's a lot of choice and a lot of overwhelming choice, especially if you've not been in this space to understand what those choices mean. And it's not just storage. The compute plays a huge part in what the ceiling looks like or what the capabilities look like from a storage point of view as well. So if we just scroll up here, we can see that we ran that test and these are our results. So we can see that we did a read test against using that block size of 4K. We used a file size of 2 gig with an IO depth of 64. This is the default setting. So you get to see that the IOPS was just short of 300 IOPS. You can start to see that the write IOPS was this and the read was that for 128K. Now, if this was your application, it would give you a good understanding of what was capable of that. But now if we kick off this next one, and now we're not using 100 gig. We're not going to use a 100 gig file now. We're going to use 400 gig or a 400 gig PVC or PV. This is going to give us insight into how different that IOPS how different the IOPS look within just simply changing that persistent volume size. So again, we run that and we'll leave that to run there. And if we go and just have a look on here again, kubectl get PV. So you can see that we've got our 400 gig PV there. We should also see our PVC as well as that pod as well. Is running that test. Again, this takes about a minute again to run this test. And I'm sure, obviously, depending on the test that you're running is going to determine how long it takes, like I mentioned, around bring your own FIO. Let's have a quick look at the... Bruce asked a question. You might be able to see these questions as well. So let's just finish. Is Kubestr forked? No, it's completely created by Suresh, who I mentioned at the top. Apart from obviously the FIO piece, we didn't write FIO. We're leveraging other open source tools and code to be able to enhance what we're doing here. Yeah, Bruce, I can share the slides as well as the recording. Yeah, exactly that, Jeff. So Jeff asked if everyone, I think everyone can see it, but if we can leverage this on Rook and Ceph and Open EBS as well. So providing that we see it as a storage class within Kubernetes, then yes, we can run a run a test against it. Jeff, good volunteering to go and run that test against that. Okay, so now we see that we've got our results back again, and we see that, let's just take the first one, for example, from a read IOPS point of view. So we see 406. Now, if we remember what it was in the first test, it was around that 300. So just the size of persistent volume changes what we have available to us from a benchmarking or from a resource point of view, from an IOPS point of view, just by changing things like, because that's the working set and the working size of that. So then we move down into, so you can export this into a JSON. Again, that enables us to do more with that. And I think this is where the community can really help, is that by taking that JSON output, we could push that into other areas so that you get a nice visual rather than all of this black and white text, this wall of text that is useful for day one. But if you're a storage consultant or you're a cloud storage expert, then you might want to be able to take that and actually document what the capabilities are in more of a not visual, in a visual manner. So I downloaded the FIO files from, and again, the links in that kubestr.io, and from there I'm going to leverage that as part of my test. So again, what this is going to do, and it will tell me at the end, but it's going to run through that same process of scanning against the EBS-SC storage class that we have. But what that is going to do, if I don't do that, if I go and now quickly go and grab that. So backwards read. And if I go and open that in, so you can see that this is going to seek back 8K off every 4K. So it's going to do very similar to what we did, but it's going to read, write, and read at 8K. The file name is going to be 128 meg, but the size is the important bit. Is it going to be 128 meg in terms of it's going to keep hammering that? And again, this will be a workload, like someone came up with this. That's why it's in the FIO repository. So it simulates a workload, and I used it because it's obviously very quick in terms of being able to test it rather than the other one. But you can see here that based on that job and the block size, etc., we get to over 1,000 IOPS from that. So what I'm saying is that by bringing your own FIO, and obviously you can go and modify this to your workload, whether it's your database based on X amount of users, you could then start to create and contribute to your FIO look as well. Okay, so back into slideware. So I think I kind of emphasize this, is that choosing your cloud storage, it could be quite overwhelming. It's great that we've got the choice, and I'm definitely not moaning about having that amount of choice, both from a compute point of view, but also a storage. Now, I've used the screenshots from Azure there, but like pick your cloud, and they have equal amounts of options when it comes to compute and storage that all play into that performance, or what that storage performance can look like. So that's another big thing, is that keep in mind that the type of nodes that you use for your Kubernetes worker nodes, they also pay a huge difference in what you see from a storage throughput or a storage benchmarking point of view. And the same when you get down into premium disk or standard disk, and then you've got managed, you've got unmanaged, you've got all of these different options. And I think the whole premise around the project is that the community can come together and run these tests and collate them, so that, one, we don't always have to run Kubestr on net new day zero environments. Maybe you want to, that's fine as well. But maybe we come up with a pool of results that enable us to have a better understanding, or having an easy way of understanding what that storage looks like from a Kubernetes point of view. Okay, so how do you get started with the project? And it might be that you just want to use it which is obviously all good. That's what it's there for. So some of the instructions are there on the left-hand side. Now, obviously you can take screen grabs of these. I'll make sure that these are sent out as well. But the two QR codes, the top one will take you to kubestr.io and the bottom one will just take you directly to the source code, so the GitHub repository for that. That website will grow as well from a contribution point of view from our side, and we expect that as soon as community contributions come in, that we'll absolutely add that there. There'll be a blog section potentially on there that highlights some of those changes. Suresh actually has done an awesome blog, not comparing clouds, because I think that's where it could get a bit sticky, in that we're not comparing the storage from the cloud because it's not an apples to apples comparison. But he went through and he did a very methodical test against like 4 of the clouds, in terms of if you had a benchmark of 4 CPUs and X amount of memory, and you took that to each of the clouds, well, these are the varying different options that you can go for from a cost point of view and things like that. So that'll be out as well with the PR release. That's going to be on the CNCF. So as we wrap this up, and we'll get to if there are any questions, but really the goals of the project, and obviously from a version 1 point of view, well, how do we make benchmarking and validating your storage easy? I think you'll see there is that was very easy to be able to, as long as you've got kubectl access to your cluster and whatever cluster that may be, then you've got the ability to run those 3 tests or checks against your Kubernetes storage. I think the key takeaway is that this should be in any operators or potentially developers that are working with stateful workloads as a handy set of tools to help debug or validate your Kubernetes storage. And kind of what I mentioned is around, if we could, as a plan for the future, allow users to post those FIO results. Now, I've mentioned a lot about community, but now start thinking about, right, if we can get AWS, if we can get the likes of NetApp or HPE or all of the storage vendors that have walked into the cloud native storage space to run these tests, then we start to get a great way of being able to understand what that storage, what the types of storage or what the performance looks like on there. And then my key giveaway, like if you're going to remember what Kubestr is in 24 hours, is that to identify the various different storage options that you have available in your Kubernetes cluster, whether that's day 0 or day 28 or plus. It's there to validate that you've configured your storage correctly from a CSI point of view, and it's there to evaluate, so making sure that the storage is going to perform at what level you need it to be. Either not make it, like, we don't want to overspend. The cloud gets very expensive very quickly. If we just go, we want the most expensive disk, we want the most expensive compute nodes, yes, we'll get all of the performance, but do we actually need it? And I would argue that actually, like, use this to be able to determine what nodes and what storage needs to look like, and then scale out accordingly as to when you need that as well. Use this as a result driven process to define what your infrastructure looks like. And then my ask to you guys, so that we can continue doing these, is take a look at the project. Not everyone is going to be a developer that can add value to this, but by promoting, by being able to spread the word around this really helps grow an open source project. Again, the same for feedback and contributions. They're obviously all welcome from an open source point of view. Spread the word as much as possible after that embargo date of 8 AM EDT time tomorrow. And another key takeaway, that handy little tool for benchmarking your Kubernetes storage. With that, if there's any questions, then happy to take them now. If not, then thank you very much. And hopefully it was useful. So Jeff, that's a good question. So this tool can really be used not just for backup storage, but also for service providers evaluating what they need for hosting. Yeah, absolutely. If anything, it's not really focused on backup storage at all, other than when you're leveraging snapshots alongside your backups, like being able to push your backups out to object storage. This is really focused on making sure that your production storage is validated and evaluated to whatever that workload needs to look like. But yeah, service providers, but really any platform, any operator that is deploying Kubernetes with a mind around stateful workloads, leveraging storage, this tool could give some insight into how to use that. Yeah, good question, Kostis. So are there any plans to add also around HTML output, or do you expect to convert the JSON? I think, again, this is us getting something out into the wild, into the community. If we've got skills in the community to be able to develop against that, then great. I'm open for any of the outputs to go. Like we were talking about potentially being able to take that JSON format and being able to push that into Power BI, for example, to better give you a look of how this, give you the visual look rather than the CLI output. Yeah, good question. Hopefully that works, Kostis. So yeah, and Joe, you're spot on. So how does this tool work with connections to multiple Kubernetes clusters? Yeah, it's whatever your context is being used at the time will enable you to run that test. So it will let you do multiple, but not multiple at once, because it's going to use the kubeconfig context to be able to get that. Oh, Jeff, that's looking into the future. I would love, especially the CSI check. This is one of the most common areas that we get, is that CSI driver not being configured correctly. The rest of it is not really focused on Kasten K10 from a backup or a data management point of view at all. But the CSI check is something that we'll be pushing to try and leverage that. And that, again, that doesn't stop. Like I mentioned at the start, from an open source point of view, we can still leverage that within our product. It doesn't then remove the community aspect of Kubestr if we're just using parts of the project. But yeah, Jeff, I'll bring it up again. I'll say that everyone on the call mentioned it. Yeah, good question, Dean. I think what the first ask will be is submitting PRs into GitHub with your results, and then we can monitor those. But so day one will be us monitoring the PRs coming in. But obviously, as this grows, there'll be more contributions, there'll be more community efforts, and we won't want to be just the sole managers or gatekeepers of the Kubestr GitHub. So as that grows, then yes, we'll be looking at how we better that process as well. Yeah, Maritz, yeah, you're following on to Dean there. And if someone can do that, then that's obviously a welcome contribution, is being able to bring in the visualization, the ability to store that data. We have Kubestr.io running on GitHub pages. If that needs to be modified in a way to be able to store this useful information, then let's explore that option. So yeah, any contact, reach out to me, michael.cade@kasten.io. I probably won't be the one to answer your technical queries, but I can put you into contact with Suresh and whoever else is working on the project. But yeah, I think with that, if there's no more questions, I think we're good to good to close the call. And yeah, please take a look at it and give us some feedback, but also play around with it. And yeah, spread the word. Thanks for joining.